Welcome everyone to another Learning at Lambert Lab session. And today's presenter is George. So over to you, George.
Thanks, Aaron. And I will just share my screen. And I'm going to just get rid of this off screen, 1 second. Okay, and I will present. So I'm not going to present at the question slide. I'm going to present at the start. So yeah, today what I'm going to be talking about is type annotating Python code with something called MonkeyType. Okay, so in prepping for this, I think I was trying to address one particular problem, and that is that as a company, we often, we sometimes, should I say, inherit code bases, often written in Python, and quite a lot of the time, they don't have any type annotations. So we're saying that they're non-typed, okay? Now, that's the way that Python code used to be written, and in some cases, the way that it is still written. But yeah, it presents some problems. It's perhaps harder to read than Python with type annotations, and also it can be very time consuming to add type annotations to a code base. So that was kind of my motivation when just thinking about something to discuss today. All right. So first of all, we're just going to go into a bit of a brief history on Python type annotations. Okay. So in the beginning, once upon a time, we had no type annotations. Okay, and I'm going to say that the code was hard to read. We couldn't generate documentation easily from code, and we couldn't run or we couldn't do any static code analysis on Python code to pick up bugs. And let's look at an example of that. Sorry, I'm just going to kill my Slack. Let's look at an example of that. So here we've got a function called repeat list as string. It takes a parameter called myList and a parameter called number of repetitions. It multiplies the list by the number of repetitions, joins, calls .join on that list, and returns a string. Okay, so here we're just calling it with a list with 3 simple strings in it and the number 2. Okay, so on the right here, I'm going to run this file, background.py, right? Now, fine, it behaves as you would expect. It converts the list ABC, it multiplies it by 2, and then joins the items in that list to return a string ABC, ABC on the right. All right, all dead straightforward so far. And that's kind of where we were once upon a time. Now, yeah, to kind of go back to the slide, if you like, that's hard to read, can't be used to generate documentation, and static code analysis can't be used to pick up bugs, right? So if you were to look at this function here, firstly, you can see like this is deliberately bad. In order to convey the types to the user or to the writer or reader of the code, probably the reader of the code, I've said repeat list as string. We're using type names in a function name, which is very confusing. And I've also said my list, which is pretty poor practice. And I'm trying to encourage whoever's using this function to pass in a list, right? But really, that should say my list of strings, right? That's kind of what the knot that we get ourselves tied into, right? The other thing is that we can't use the type checkers. So if I were to call this with 2.2, then we would get a type of error? A type error, saying we can't multiply a list basically by a float. All right. So that's where we were once upon a time. If I now just comment that out, flip back to the slide. Kind of next up, in Python we have this concept of docstrings. So we added, I'll do it down here actually, one I prepared earlier. So almost, well, an identical function. And here we've added a docstring to a function, which can be used to add some information about the function and its argument, sorry, its parameters to shows the user. Okay, so we're saying that, yeah, the param, my list, yeah, that should be a list. Although interestingly, I haven't done a list of string. I actually don't know whether, if I'm honest, whether the docstring supports that or is intended for use with that. Number of repetitions, yeah, I've said that's an int, and we can specify the return type as well. That's a string. Now, that's great, and it was an improvement. It makes the code a little bit easier to read because it's easier to understand. Docstrings can be used to generate documentation, which is nice, but I still don't think, although I'm happy to be corrected, I haven't used any static code analysis, which will actually essentially pass, really say, well, number of repetitions here is specified to be an int. What happens if you pass in a float? Is there a static code analyzer which will pick that up? I haven't used one. If there is, then it's a regression, in my opinion, for us to go back and investigate it and spend time using it. So we're actually going to bypass that, if you like. So yeah, that was next up. Then what do we have now? And for the last few years, it's an improvement on no type annotations. It's an improvement on docstrings. It's to use type annotations. These are easier to read and self-documenting. We can use them to generate documentation in some cases, and we can also use static code analysis tools to pick up type errors. And in this case, the static code analysis tool that we use most of the time is a Python package called MonkeyType. So let's look at another file where I demonstrate this. So again, it's essentially identical function, but we are specifying the type of my list, should be list. We're specifying number of repetitions, should be an int, and we are specifying a return type here of string. Now, actually, I've already just spotted a mistake in my code. Well, not a mistake, but something which should have, basically, by doing this, I shouldn't be calling this my list anymore. That was to demonstrate bad practice. I mean, this, I don't know what you might want to call it, but the idea is that the type is inferred from here, right? So that's great. If I execute the code with the number 2 here, so oops, Python background 2.py, it runs as you'd expect. But let's just, if I change that to 2.2, and I'm going to use MyPy, just for your benefit, in my virtual environment, I've got 2 packages, MonkeyType and MyPy, and I'm running, I think Python 3.7, 3.7.6, so nothing fancy going on there, all right? So, sorry, if I come back to my file, I'm going to run a static code analysis tool called MyPy on it, background 2.py, and it will find an error, okay? It will say that it was expecting this argument here, number of repetitions, to be a float, sorry, to be an int, but we've passed in a float, okay? So that is a nice feature of type annotations, right? Now, that's our brief history done. If we just go back to our problem a second, this is the problem we're tackling, is that we're inheriting lots of Python code bases that aren't typed. And they can be gigantic, as we know, right? So yeah, what's the solution? Well, a solution, I'm going to go for at least, is MonkeyType, okay? Python package that turns untyped Python into Python with type annotations. It comes out of Instagram. They've open sourced it, so it's on Typey. And yeah, I've just written here, it's not to be confused with this MonkeyType, which MonkeyType apparently is something which helps you to type at speed. but that's not what we're interested in here. Okay, so one sec. Yeah, so I'm gonna demo using MonkeyType, okay, to add type annotations automatically to our code base. So to demonstrate this, I've put together, I'm just going to close those two background files, share these. Yeah, we've got two files now, a main.py and a problemcode.py. Now, problem code just has two functions. One is repeat list of string, which is untyped here, and the other is just an add function, which takes parameters A and B and adds them together, right? In main on the right-hand side, we just call both functions, okay? So nothing fancy at all going on there. And if I just run Python main.py, yeah, it adds together 1 and 2 to return 3, and it does our transformation on our list as we've been doing previously to return this string here. Okay. Now, what we're going to do is use MonkeyType to add type annotations. So our first command here is MonkeyType run a file.py, or sorry, we're going to use main.py here, and what we're saying is that it dumps all of the function call traces into a SQLite database. All right, so let's flip back here, and I'm going to run MonkeyType run main.py, because main.py is where these functions are actually being called. Okay, so I run that. As you can see, it actually executes the file. Okay, that's kind of a byproduct. Well, it's not a byproduct. It's required, but we're not interested in the output, is what I'm saying. What we're interested in here is the fact that if I do an ls, it's now just generated a SQLite 3 database where it's thrown basically details around these two function calls into that database. So I'm going to dive into that database. If I can remember SQLite 3, oh, one out. SQLite 3, so I'm in the SQLite command line now, and I'm going to do dot open on MonkeyType SQLite 3. So I'm going to open up that file. I can show the. I've done something wrong here. Sorry, I have. If you might have noticed, I've just misspelled MonkeyType there. I think that's the problem. Hope this will now work. So I've opened up that database file, and yeah, okay, this time if I call to show the tables, I get one table, okay? MonkeyType call traces, and I'm going to do select star from MonkeyType call traces, and we get some information. I think there's actually just 2 rows in this database, 2 rows in this table, should I say, one representing each of these function calls here. And yeah, let's see if I can make that a bit clearer for you. We've got the first call. It says, yeah, in the module problem code, sorry, yeah, in the module problem code here on the left, the function add, it says that A, that parameter there should be an integer. It says that B should also be an integer. And then the last thing here is the return type. It's saying should also be an integer. Okay, all good so far. And then for the second function, repeat list of string, it says we've got my list, which should be a list of strings, which is correct. And it's saying that number of repetitions should be an int, and it's saying that the return type should be a string. Okay. So for now, we've just thrown this all into a database. The next command we will use is MonkeyType stub, which is basically going to take that information that we just saw in the database, and it's going to output a preview of our annotated code. So if I come back here and run MonkeyType stub problem code, so our module, it's going to output what it thinks the code should be as a preview for us. So yeah, it's saying that add should add type in int, and a return type of int as well. Great, that sounds good to me. And it's adding the type in list strings and int and string to our repeat list of string function. So that's just kind of a preview mode, if you like. That's great. And then our third command is MonkeyType apply. So that's actually going to just apply what that preview we just saw to our file. So MonkeyType apply problem code. And now if I click in my editor, I think, just to refresh it, yeah, there we go. You can see that on the left-hand side, problem code.py is now, in a sense, inaptly named because we have got type annotations, which is quite nice. Now, one thing you may or may not have picked up on is that there are some limitations. And I've written a question here saying too much influence, right? So this add function here actually comes directly from the MonkeyType kind of first page of documentation, right? And it's great because we've added in here, which is the behavior conveyed when we call it with the integers 1 and 2. But the problem is that, or a potential problem is that the initial definition of this might have been intended for other use cases as well, right? This, at the moment, if you look at what we've got on the left, that could be, A and B could be strings, they could be lists, they could be integers, they could be floats, they could be various different data types and data structures. And so a limitation of MonkeyType is that if we just call this function once with only one of those data types, integers, then it will enforce that this function should only be used with integers, which, you know, that's a narrowing down of its functionality actually, and yeah, a potential limitation or drawback. Good. So, I mean, just to sum up on that, sorry, that's it. Dead simple. MonkeyType, one Python package, incredibly simple, but I think that as a company, we should start using it more widely than we are currently doing. So I would encourage you all to, you know, have a play with it, if you like. And then I've just kind of got a note here saying what next, or maybe it should say what else. As a software development company, yes, we build new products, but also we do inherit code bases. And inheriting code bases means that we need good, quick solutions for improving code bases that we inherit. So I would encourage everyone to keep exploring avenues for how we can, ways that we can automate improving outdated or inherited code bases. A couple of things that I've made a note of here are Python has a built-in module which at least allows or helps you to convert Python 2 code to Python 3, which is in some cases relevant. And I know that we've used that as a team before. And I've also just put a link here to a npm package which I have not investigated at all. The clues in the name, JS to TS converter. So the idea being that it helps in some way, shape, or form with converting JavaScript to TypeScript, but I really haven't delved into it. But for those of you working on JS, TS projects right now, it would be relevant to explore, at least have a 5-minute read. That's everything. So we'll open the floor to any questions.
I have a question, George. On the, could you possibly go back to the problem code.py module?
Yes, sir.
Yeah, and it's interesting that it because I can't remember the command, but it was MonkeyType stub or something like that on specifically just the problem code module, and it kind of said that my list, that argument there was, it was definitely a list. how does it do that? How does it know that it's a list and not say a tuple? Because I think I'm right when I say that it could have been a tuple. So
it comes from, I mean, I'm a little confused, I suppose, but it's coming from here, right? It's coming from an actual call to the function. Does that make sense?
yeah, I think that makes sense when you do it on main.py, but I think the command was on.
Yeah. Okay, yeah. It's because it's reading it from a database. So the initial command, the first command I ran, Aaron, was MonkeyType, Christ, I can't remember now, run main.py, right? Okay, that was the first command. And I'm not going to run it again right now, but that put this data into the database here. It's actually still on screen down below here. And so it says that call, repeat list as string, is in the module problem code, refers to a function in the module problem code. And it gives all of the type, essentially all of the information that's needed is in the database now, right? So the subsequent command, which is MonkeyType, lost it now, which is MonkeyType stub problem code. That's the one you're talking about, Aaron. That's reading from a database. Now, if I'm honest, the use of the database here, that's something which isn't kind of explained in the documentation, like why is there this database? Because it's splitting out something that could be done in one step into 2 or 3. My hunch would be that when you're rolling this out over large code bases with a lot more complicated code than I've shown in this demonstration, that for some reason the database is just very useful for keeping a record of what's going on. That would be my take. But I think when it runs MonkeyType stub problem code, Aaron, it's reading from problem code here is performing a SQL lookup on a SQL query on here, looking for the module name, right?
Yeah, thank you. That makes a lot of sense.
Yeah, this isn't so much a question or as a comment, but I wonder how MonkeyType deals with sort of more complex types. Like I'm thinking, for example, of in Django, you have a view which takes in a request. That request is a special request object. I wonder if my MonkeyType kind of can properly identify that as a Django request object. But yeah, I don't know. Maybe it does. If it does, that'd be quite impressive.
I mean, my understanding, Tom, is that it would do. I don't have a bit of code to demonstrate that to you right now, but it is an very established package.
Yeah.
If we look on GitHub, I mean, yeah, 3.4K stars tends to mean that it's popular and in use, and so I would imagine actually, Tom, that it does support that without me having actually concrete examples to show you right now. Yeah,
it'd be worth trying out, I guess.
Yeah, definitely. I mean, what might be more challenging there is that you have to use you have to be able to run the code So, I think the first command I ran, which threw the data into the database, was Python run main.py. Now, that works absolutely fine in kind of when you've got a script, right? Now, because it actually runs, oh, sorry, where am I? Okay, oh, yeah, that should be MonkeyType, sorry. MonkeyType run main.py. That's fine when you've got a script which just executes easily. Now that might get more complicated in a Django project, for example, or some other project with more complicated types where you're not necessarily actually intending to run that function in this way, if you like. Yeah.
Yeah. Thanks.
Cool. Okay. Well, I would say that if we don't have any other questions, I think there would be a good time to stop. So I'll pass back to Aaron.
Thanks for your presentation, George. And yeah, thanks everyone for listening.